Yeah. Check it out.
Hello and welcome to the video on graph sketching and asymptotes. Okay, so basically, with what we know now, with the information we have about f prime and f double prime, so the first and second derivatives, we can sketch the graph of f if we're given a function. Okay, so here's some important things to note when you're going to graph a function. So important things to note. So the first thing is the transition points. Okay, so transition points, also known as critical points or points of inflection. So transition points are basically points at which, so where our f prime, so the first derivative and the second derivative, where they all change signs. Okay, where they change signs, those are really important. Okay, all right, and then let's see what else we need to note is sign analysis. That's pretty important. So basically knowing when our f prime and f double prime, when they're positive and negative, what intervals. Okay, so sign analysis of both the first derivative and the second derivative. Okay, on intervals. So that's important. So on in what intervals. Okay, and one of the last things to note, amongst other things, is the behavior at asymptotes. Asymptotes. Okay, so asymptotes meaning like vertical asymptotes, horizontal asymptotes, anything like that, when your x is going to either negative infinity or x is going to positive infinity as well. Okay, all right, so it's kind of basically like we're going to gather up as much information as we can about a function, about its first derivative, its second derivative, and this and that, and on the intervals, and then we're just kind of going to spit it out. And it's kind of like I think of it as like a squirrel. We're being squirrels and we're gathering up acorns kind of thing, and then we're just going to use it to fuel our graph making skills. So anyway, something important to note, so here I'm going to draw like a little bit of a chart here. Okay, so we'll draw like a 4 squares thing. Okay, so 4 things can happen when you're sketching a graph. So let's look at it. So let's say our first derivative is positive. Okay, so that means that our graph is increasing. Okay, let's see what else. So if our second derivative is also positive, that means that we are concave up, right? Okay, so what does that mean? So increasing, so that means we're getting bigger and bigger. Our function is growing greater and greater, and we're concave up as well. So that would look like something like this. Concave up like a cup, and our function keeps increasing. Okay? Now let's look at the case where we're also increasing, right? Our first derivative is positive, and we're increasing, but now our second derivative is negative. So that means that we're concave down. Okay? So here again, we have to keep going up and up and up, but now we're concave down like a frown. So what this means, that would look something like that. Okay? So something looking like down like a frown, but still our function is increasing. Okay? And now let's turn over to when our first derivative becomes negative. So that means we're decreasing, our function's decreasing, becoming lesser and lesser. And our second derivative is also negative. So that means we're concave down. Okay, so now we're decreasing. So the function values are becoming smaller and smaller, and we're facing down like a frown. Okay, so it looks like that, something like that. Okay, and then the last case would be if our first derivative is again negative, so we're decreasing, our function's decreasing, but this time our second derivative is positive. So now we're concave up again, like a cup. Okay, so our function's going down, but we're concave up. Okay, so something like that. All right, so those are basically the 4 different kinds of graph pieces that we can find. And what our goal is going to be is that when we're given a function, we're going to find out as much as we can about the first derivative and the second derivative, on which intervals each of those are positive and negative, and then kind of break it up into those intervals and just stick these pieces in accordingly. Okay, so let's do an example of that. So what we're going to do is sketch graph of, and I'll give you a function, f of x is equal to x squared minus 4x plus 3. So this is a pretty simple one, okay? So first of all, like I said, we're going to gather as much information as we can about both the first and second derivatives. So our first derivative is going to be 2x and then minus 4, okay? So this equals 0 when our x is equal to 2, right? Because then we have 2 times 2 minus 4, that equals 0. So this is a transition point, okay? And then now let's find what is our second derivative. That is going to be 2. Okay, so that's a positive 2. There is no transition point because it's always going to be positive. Okay, so this is a positive value. And now so we found our first and second derivatives. So this is always going to be positive, so there's no transition point for the second derivative. Transition point. So that means there's also no point of inflection, right? So this means our graph is always going to be concave up. Concave up, okay? And now let's look some more at our first derivative in detail. So let's see what's going on there. So first derivative, and let's do our sign analysis. So we're going to plant our critical point here at 2, okay? And then it goes to the left for negative infinity and to the right for infinity. And then so let's pick an easy point. So let's pick 0, and then we'll pick a 4, okay? So if we plug in a 0 to our f prime, we get f prime of 0 is equal to 2 times 0 minus 4. So that's definitely a negative 4, so that's a negative number there. And then if we plug in a 4 into our f prime, that's going to give us 2 times 4 minus 4, which is 8 minus 4, which is a positive number. So that would be a positive, okay? So here we see that our f prime, changes from negative to positive. So that means our function goes from decreasing to increasing, okay? So we're at a local minimum, okay? So we have a minimum here at x equals 2. All right, so let's make a little bit more sense about what we see here. So what I like to do, once I gather all the information about my first and second derivatives, is I like to make a chart, okay? So here's our f prime, and here's our f double prime. So we know that f double prime, so let's make, like I said, we're going to make a chart, all right? So f prime, it starts from decreasing, right? Remember, we started off negative, and then it switched to positive, and that point was at x equals 2, right? That was our critical point, okay? So at that point, we had a minimum, so this is a minimum here. So we changed from decreasing to increasing, all right? And our interval, like I said, the critical point was 2, and there was no other critical point, so that means that this interval has to be negative infinity up to 2. And then we have 2 here sitting there, and then we have 2 to infinity as we continue on to the right. And then f double prime, we found that to equal positive 2 for all x, so that means it's just going to stay positive for both of these intervals, right? For all of the real numbers, okay? So there is no point of inflection here or anything like that. But the positive, that means that we're concave up on both of these intervals, okay? So now what we do is we look at the columns, okay, as the intervals. We look at the columns together and we analyze what's going on with the f prime and f double prime, remember? So here's where our pieces of the graph come in. So if we just were to kind of just imagine like what this graph looks like, so for this interval here, for this one, our negative infinity to 2, we have f prime being negative, so that means decreasing function, but our f double prime is positive, our second derivative is positive, so that means we're concave up like a cup, so something like that, okay? And then for this interval over here, we have increasing function and concave up, so it looks like this. So if we just stick them together and join these two at the point x equals 2, then we can draw our graph or sketch our graph. Okay, so let's do so on the next slide. So we have a graph piece that looks like this, from negative infinity up to 2, and then from 2 up to infinity, we have a graph piece that looks like that. So if we put them together, then we get that our f of x is equal to x squared minus 4x plus 3, that this simple graph, it basically looks like a parabola, and we can always get more information about it by just solving for like what are the x-intercepts, so we can break that up into x minus 3 and x minus 1, so we see that the graph is equal to 0. It touches the x-axis at x equals 1 and 3, okay? So if we were to do that, this is just being more accurate, right? So we have 1, 2, 3, 4. So here's 1, 2, 3, 4. So it touches it 1 and 3. And we have these two pieces are being joined at x equals 2. So that means this is the bottom of our U, okay? So something like that. All right, and thus we have sketched a graph.
For real, I ain't trying to hear nothing unless it's about the progress or about production. Shit, we just out here trying to function from Saga City out to